Hey guys, Ian here from the eChook Nano development team. An exciting day indeed because my first shipment of the version 1.1 board of the eChook Nano has arrived. We've got version 1 here, all mostly built up. Some teams might recognise because we've got about 10 of these being used currently by teams being tested. We've learnt a few things, we've redesigned some bits. Majoritively all the same sort of stuff, so we're going to be able to be fairly backwards compatible in terms of code and even connectors with the version 1 board. That's to mostly make our lives easier, but if a school's already wired their board or their car for one of these, they should fairly easily be able to move to one of these. All the code should be cross compatible, and we use the same app on an Android mobile phone. So this is more like the kind of boards we're going to be seeing from now on. It's ever so slightly smaller in footprint, but a lot of that has been because we've had some feedback that our connector here for the Bluetooth, often on the cars rattling around track, you find that the Bluetooth works its way free, you don't get a very reliable connection. We found on our car actually what we did for most reliable connection was actually mount the Bluetooth module off board anyway. So the Bluetooth module is now here. Hopefully the camera's going to refocus reasonably, but it's in this top corner up here. The reason being is that we expect people to, maybe in testing, potentially use it there, but later on in the development stages, perhaps you'd be mounting a Bluetooth module externally on a section of cable, just into, hopefully I'd like to see some 3D printed cases for these. Unfortunately, your camera's not focusing that well in the light. Unfortunately, we're not in a professional studio. We're just in my bedroom in Leamington Spa, but we'll get there. So changes to this board. Hopefully, as well as that Bluetooth upgrade, we've designed our own switch mode power supply. So that gives students a little bit more soldering to do. It's a little bit more in depth in terms of a classroom lesson. In order to kind of teach around this, but potentially that's something we could investigate at a later date. Obviously the kind of board here and the whole idea of the project really is kind of a learning experience for the students and the young people involved in green power as a project itself. So we've got the upgrade to the power supply. We did have some problems with the previous power supply design. That's one of these cheap units from China. Just a couple of those blew up on us, so we've incorporated some reverse polarity protection in here and some over voltage protection, so hopefully that will be a little bit more of a robust solution. What we've also done is try to put connectors just on these two sides of the board here, and every pad on this board, where some were perhaps a little small on the original version, put a little bit more meat around the pads, specifically the resistors and the capacitors on the board. That's just to make it a little bit easier to solder for small hands. The other thing that I've done on this design is all the components are actually on the top side, and the bottom side will purely be for soldering. So you should do, I think, a majority, if not all, of the soldering on this side, which should make things a little bit easier and a little bit easier to debug and possibly a little bit easier to understand in comparison to this board here, where we had some components sort of underneath things and some on this side and some on this side. It's a little bit more complicated. The one connector that we have changed, not in terms of pin out, but just in terms of physical style, is actually the power in connector. I'm just waiting on a shipment of these, but that is a slightly smaller pitch spacing. The reason being on that is because we wanted to have some level of difference between that and the other connectors, just because we don't want students plugging power connectors into, say, this thermal input here, or sorry, throttle input here by mistake. Hopefully that will avoid that happening so much. What I'm going to do with this board, now we're a little bit more settled with the design, is try and take you through, in the form of videos, a full build process from start to finish. I'm going to get to doing that today, so hopefully over the next couple of weeks we'll have some videos out there explaining how to put one of these together, and then to kind of accompany those videos, also hoping to have some instructions or kind of lessons that can be used in the classroom or at home to explain just how this board is working. To that end, some of the complexity has actually been stripped out of this board where it wasn't required. We had some filtering in there that wasn't needed, so the actual component count's slightly reduced on this board, but the feature content is still there, so it should still do all the same things. We might handle some more filtering in software for certain inputs, but we expect that everything from our testing will be perfectly fine. To that end, some of the components on this board aren't even populated because they just weren't necessary. This board we think is just, it's the kind of the perfect mix of the simplicity as well as the good engineering. So it'll be great for testing, great for teaching, and hopefully enable you to get some great data from your cars. So I'll get back to you in the form of these videos when we've got a bit more along the way with putting one of these together.